However, in this video we will solve problem 4.15 from the book Applied Thermodynamics, Meconic Entities Tube. Here is the statements of the problem 4.15. A certain perfect gas for which gamma is 1.26 and the molar mass is 26 kJ per kmol expand reversibly from 727 centigrade 0.003 meter cube to 2 centigrade and 0.6 meter cube according to a linear law on the TH diagram. Calculate the work done per kilogram of the gas and sketch the process on a TH diagram. So first, the gamma that is provided is 1.26. Next is the temperature T1 that is given 727 centigrade. Convert that into Kelvin, so it becomes 1000 Kelvin. The initial volume that is provided is 0.003 meter cube. And the temperatures, the final temperature is T2, that is 2 centigrade. Convert that into Kelvin, so it becomes 275 Kelvin. So after expansion, the volume reached to 0.6 meter cube. Let me draw its TH diagram. So this is the low volume line. This is the high volume line. Since expansion takes place from process 1 to 2, 1, 2, change in entropy will occur. That is obvious. This is S1 and this is S2. Now this is volume V1, that is 0.003 meter cube. This is the volume V2, that is 0.6 meter cube. The temperature T1, that is 1000 Kelvin. This is T1 temperature. And the temperature T2, that is 275 Kelvin. So this is the sketch, TS diagram sketch. Before moving toward to solve this problem, remember whenever there is a change in entropy on the TS diagram, for the sake of simplicity to solve it, divide this process 1 to 2 into two processes. Let's say one is to taken place at a constant temperature and the other is taken place at a constant volume at V2, that is 0.6 meter cube. So the process that takes place from 1 to A, and then the process that is taking place from A to 2. So the change in entropy when the process follow this line at A is SA. This is taken at a constant temperature and this is taken place at a constant volume. Now the universal gas constant, that is 8.314 kilojoule per kg Kelvin. The molar mass of this gas is given, that is 26 kg per kilomole. We need to find the gas constant for the statement that is provided, and it will be equal to Ru divided by its molar mass. So 8.314 divided by 26 and you will get its value, that is 0.3198 kilojoule per kg Kelvin. We need to find the CV value also, that we'll use in this process A to 2 to find its change in entropy. It will be equal to R divided by gamma minus 1. So what is R? That is 0.3198 divided by gamma, that is 1.26 minus 1, and you will get its value, that is 1.23 kilojoule per kg Kelvin. Now the net change in entropy is equal to S2 minus S1, and that is equal to SA minus S1. So that is the process 1 to A taken place at the constant temperatures minus SA minus S2 that is taken place from process A to 2 at a constant volume. So this change in entropy from process A1 to A is taken place at a constant temperature, so it will be equal to R ln V2 divided by V1. V2 is the final volume, V1 is the initial volume, minus CV that is taken place at a constant volume, that's why we will provide here CV ln and then A to 2 at a constant volume. So we write the CV, and in terms of volume now we write the temperature, the higher temperature T2 divided by T1. Now put the value, what is R? That is 0.3198 ln V2, that is 0.6 divided by 0.003 minus CV, that is 1.23 ln 1000 divided by 275. When you simplified it, you will get the change, the net change in entropy from process 1 to 2. You will get that is 0.106 kilojoule per kg Kelvin. Okay, next we need to find the heat that is supplied, that is equal to change in entropy, the net change in entropy from process 1 to 2, and the average temperature, that is T1 plus T2 divided by 2. So the heat that is supplied, change in entropy, is 0.106 multiply with the temperature 1000 plus 275 divided by 2. After calculations you will get its value. So the heat that is equal to 67.6 kilojoule per kg. So this is much heat is supplied when the process follow expansion takes place from process 1 to 2. So the heat is supplied to the system when it follow the expansion from process 1 to 2. Next, the work done by the system according to first law of thermodynamics, that is equal to heat that is supplied minus change in internal energy minus change in entropy. It will become CV, change in temperature, T2 minus T1. For the work done you will obtain, that is 67.6 minus CV 1.23 into, that become, what is temperature T2, that is 275 minus 1000. So upon simplifications you will get the work done by the system is 959 0.3 kilojoule per kg. Now this is work done by the system because expansion takes place in this process. That's why here you will write the negative sign, because work is done by the system in this problem 4.15, and that is our final answer. If you have still any confusion, you can ask in the comment sections. I will respond accordingly. If you haven't subscribed my channel yet, please subscribe. Thank you so much.